Okay, we're looking at displacement, velocity and acceleration here. Displacement's normally denoted by S for reasons that are best known to other people actually, but there you go. And when you see one of these, you get something involving a formula in terms of T. Okay, T for time. Okay, and it will normally say that in the question somewhere. Okay, so it says we need to find the velocity and acceleration after 4 seconds, which means we've got to differentiate. So ds dt, alright, so we're differentiating in terms of t. Okay, so that's going to be 3t squared minus 8t plus 3. That's going to be v. Okay, so velocity is a change in, if you think about it, alright, velocity is the change in displacement, how far you've gone, over the change in time. Okay, so there you go. Now acceleration, okay, is dv dt. So you just differentiate what you've just got by differentiating the displacement. Okay, so differentiate 3t squared, we get 6t minus 8, and there you go. Now all we've got to do is, and if you think about it again, the acceleration is the change in velocity over time, change in time. Alright, now we need to calculate the velocity and acceleration after 4 seconds. Okay, so we just substitute 4 in for t, and we get v equals, what was that, 19 meters per second. And we get A is 16 meters per second squared. Alright, so all I'm doing is substituting 4 into here for that one and here for the acceleration. Now part B says find the point at which the acceleration of the particle is 0. So all we've got to do is use this here, which we got in the, sorry, not that there, I mean this here. Okay, and make that equal to 0. Right, so that's when the acceleration is going to be 0, and solve to find t. Alright, 8, so therefore t equals 8 over 6, alright, or 4 over 3 seconds, so 1 1/3 seconds essentially. Alright, so there you go. Things to remember is displacement differentiates to velocity, which then differentiates to acceleration.